All right, let's start talking about the warm-up. So we want to put these three fractions in simplest form, just like we did yesterday on the warm-up. That means I need to look for common factors, things that will go into both the numerator and the denominator, things that will divide them evenly. So looking at the first one on the warm-up, number 3, 95 over 240. What number can you think of that'll go into both of those? 5 goes into both 95 and 240. And what is 95 divided by 5? 19. And 240 divided by 5? 48. And then we have to check to see if that is simplest form. Is it fully simplified? So I have to know numbers that go into 19 and numbers that go into 48 and see if they have anything in common. What goes into 19 evenly? Just itself, right? 19 is the only thing. 19 and 1 are the only things that go into 19. So in order to reduce this further, 19 would have to go into 48, or else I've got it in simplest form. Does 19 go into 48? No. So 19 over 48 is our simplest form. Number 4, we have 51 over 540. Are there any numbers that go into both 51 and 540? 3. So we can divide the top and the bottom by 3. What is 51 divided by 3? 17. And 540 divided by 3? 180. Got to check to see if we are in simplest form. So I would need something that goes into both 17 and 180. What numbers go into 17? 17 and 1, and that's it. 17 is a prime number, so it's only 1 in itself. Does 17 go into 180? No. So 17 over 180 is simplest form. Last one on the warm-up, 189 over 300. What goes into both 189 and 300? 3 goes into both. What is 189 divided by 3? 63. And 300 divided by 3? 100. All right, time to see if it is in simplest form. They seem like pretty large numbers, so we might be able to get them to reduce. Also, I know 63 is not a prime number. What numbers go into 63 that we should see if they go into the bottom? 3 goes in. What else goes into 63? 7. What else? 4 does not. 9 does. And then if you do 63 divided by 3, you get what? If you do 63 divided by 3, you get 21. So 21 also goes into it, right? Because if I do 63 divided by 21, I would get 3 back. So 21 also goes into it. And then, of course, it goes into itself, right? Do any of those numbers go into 100? List off some things that do go into 100. 10, 5, 2. Does 4 go in? Yeah, because 4 times what would give you 100? So 25 goes in. I can probably stop my list here. That's not all the things that go into 10, but a lot of times when we're reducing our fractions down, we're looking for small things that go into both the top and the bottom, and I'm sure I have all the small ones with 2, 4, 5, 10. Do we have any factors in common between the numerator and the denominator? No. Only 3, 7, 9, 21 go into 63. And other than 5 and 25, all the other numbers that go into 100 are even. 5 and 25 don't go into 63. So 63 over 100 is simplest form. That does not reduce any further. All right, good job on the warm-up. I need you guys to grab that extra notes packet that you should have picked up on your way in the door. Is there anybody that did not pick up the extra notes packet on their way in? We are exclusively going to be in this extra notes packet today. We usually tend to go back and forth on extra notes and books, so make sure you've got your book with you every day because we'll be going back and forth between these two things. For the most part, we're not doing anything brand new. We might do some clarifying of things that we talked about yesterday or a little bit of expanding, but nothing brand new today. We're just going to be reviewing what we learned how to do yesterday and do a couple more examples there. So yesterday we learned about dilations. Dilations change the size, but not the shape. Dilations change size, but not shape. We say that the shapes are similar. And we represent similar with that squiggle. The shapes are similar, not congruent. So let's see what we can do with what we learned yesterday and what we've got to work with today. Number 2, part A says ABCD is dilated. So if I take a shape and I dilate it, then that means that shape right there that I started with, that is my original. So this shape right here is what we started with, my original shape, which means that EFHG is my new shape. They want me to find the scale factor that it was dilated by. And yesterday we learned that scale factor is equal to new over original. Six over 18, and you just hit on a really good point that I was going to ask, but you beat me to it. How did we know it had to be 6 over 18 and not 6 over 12? Yes. We have to make sure that we match up the corresponding parts. One of the things that I was looking at here, because we've got these 2 trapezoids, your explanation was perfect. I have a slightly different way of explaining it, but neither one of these is wrong. When I look at the new shape, the only side that I have information about is this bottom piece right here. But I'm not necessarily looking for things like top, bottom, left, and right. Because I could take any of these shapes and twist them around, and I would still have to make sure to match up my corresponding parts. What I notice about GH down here that's 6 units long, it is the longest side of that entire trapezoid. So when I go to match it to its corresponding part on the other trapezoid, I need the longest side on that trapezoid, which is down here, CD. That's how we knew it had to be 6 over 18, new over original. What goes into both 6 and 18? Because it's not in simplest form. How much? 3 goes into both of them, so let's reduce the top and bottom by 3. What is 6 divided by 3? 2. And 18 divided by 3? 6. Are we in simplest form yet? No. What goes into both 2 and 6? 2 goes into top and bottom. And so that would give me what as my scale factor? 1 over 3, 1/3. Yes. Can you flip the fraction the other way? No. Good question. If they hadn't told me at the beginning that ABCD is dilated by, if I didn't know that one was my original, then I could say something like, well, for an enlargement, it would have to be this, but for a reduction, it would have to be a different one. And that's when we flip those fractions either way. So we'll look at that in just a second. But because it said A, B, C, D came first, we took that and then we did something to it. We have to have the original, which in this case is the bigger number, on the bottom. Does that help? Okay. You're welcome. All right. There's another part to this question. We found our scale factor. It's 1/3. But they also want me to find segment EF. Is EF on my original or my new shape? EF is on the original over here. It's on the new one. This is what we're looking for here, EF. Do we know how big the corresponding piece is on the original? 12. There we go. These are corresponding pieces. So I'm going to use, again, what I know about scale factor. Scale factor equals new over original. We just found our scale factor right here. That scale factor works for every pair of corresponding sides on these two shapes. So my scale factor is 1/3. We're looking for EF, which is on my new shape. I don't know how big that is, so I'm just going to leave it as EF. But you told me we did know how big the corresponding piece was on the original. How big was that? 12, so that goes down in my denominator. And now I need to solve this for EF. To solve it for EF means I need to get EF by itself. And right now, EF is up in the top of that fraction. It's up in the numerator. So I got to figure out how to undo a fraction. We could, absolutely. And if you're comfortable doing that, go for it. When you see a fraction, what operation's happening? Division. And we said we wanted to undo that fraction. We want to get rid of the fraction. So what operation undoes division? Multiplication. And if you do it to one side, have to do it to the other side. What we want to multiply by, when I want to get rid of a fraction, I have to multiply by whatever's on the bottom of the fraction. EF is the thing I want to get alone. What's on the bottom of that fraction? 12. So I have to multiply both sides by 12. Both sides, left-hand side of the equal sign and right-hand side of the equal sign. So I have to multiply the 12 to this right here. That's going to make the 12 cancel because you're dividing by 12 and multiplying by 12. On the other side, I had 1/3. So now I'm taking 1/3 and multiplying it by 12. What is 1/3 times 12? One-third times 12. 4. Yeah, if you do it the other way around, then you'll get 36. But we wanted to do the 1/3, so it's kind of like the same as dividing there. So EF is 4 units. Nope, we're multiplying, because remember, multiplication is what we use to undo the division, and division is what we needed to cancel out on the other side. So whatever you do to one side, you have to do the exact same operation to the other side with the exact same number. Good questions, good observations, guys. For part B, I want to look at both when we have RSTU as our original, and I also want to look at when MNPQ is the original. So let's do the first part, the top part. I know RSTU would have to be the original here because it says from this. From this to my new one. We always go from the original to the new one. RSTU is the one up here on the left. So So if that's my original rectangle, and MNPQ is my new rectangle. I've taken this one right here and I've dilated it to create this one. Is that an enlargement or a reduction? Enlargement, it's getting bigger. What does that tell me about the scale factor? Has to be bigger than 1. All right, so let's set up our scale factor. I need to make sure to match corresponding sides. New goes in my numerator. Original goes in my denominator. I've got 2 sides on RSTU. Do I know what the corresponding sides are on NMPQ? Yes. What is corresponding to 21 feet on NMPQ? 28 feet. So these 2 would go together. Which one would go in my numerator for this first part here? 28 would go in my numerator. And 21 then would have to go in my denominator. Don't we have another pair of corresponding sides between the 2 rectangles? What are the 2 corresponding sides that I have other than that? 9 and 12. If I were to set up that fraction, which one would go in the top? 12 would go in the top. And 9 would go underneath. If I have correctly matched up the corresponding sides, it doesn't matter which one of these I use, I'm going to get the same answer either way. Is 28 over 21 in simplest form, or can something go into both of those? What goes into 21 and 28? I know 3 goes into 21, but 3 doesn't go into 28. What'd you say? 7. 7 goes into both of these. Yes, and you get 4/3 when you do that. Same with the other one, only what are you dividing by that time? That one you can divide top and bottom by 3. 12 divided by 3 gives us 4. 9 divided by 3 gives us 3. So I get 4/3 either way. And how do we know that that's an enlargement again? It's bigger than 1. Numerator is bigger than the denominator, or if I want to double check, I can put it in my calculator. I can do 4 divided by 3, and I get 1.3 repeating. So it's bigger than just the whole number 1. This is our enlargement. What about if we switch it around the other way? NMPQ is now my original. And RSTU is now my new. 3/4. Tell me how you did that. It's absolutely correct. That's absolutely what we do. If my original and my new switch places, then the top and bottom of my fraction are going to switch places because now the new is opposite of what it was before. So I would have 21 over 28 or 9 over 12, or you could jump right to their simplified form. That would be 3/4 either way. What is 3/4 as a decimal? Does anybody know? 0.75. So that would make this a reduction or an enlargement? Reduction. How do I know? Because it's smaller than 1. Specifically, it's in between 0 and 1. So it's a positive number that's smaller than 1. Fantastic work so far. Let's look down at number 3. Look at an actual application of this idea. Using the picture to the right, How can you find the distance across the lake? So there's two different triangles that I see when I look at this picture. There's this itty bitty triangle right here that's formed by B, D prime, and E prime. Do you guys see that itty bitty one there? And then there's a larger triangle that starts at B, goes up to D, goes across the lake, and then back to B. Do you guys see my two triangles there? Super tiny, and then the large one that actually goes across the lake. We want to try to use what we've learned about similarity, about dilations, and scale factor to figure how far it would be across the lake. I know that scale factor is new over original. Are you guys okay if we call the tiny triangle our original one, since we know all three sides of that? Technically, they didn't tell me, so I get to choose, but I'm just trying to make it easier on myself. I'm putting the things that I know down in the denominator. So from B to D prime, this bit right here, I know that that's 4 feet. So I would put that on the bottom. The corresponding side to that, well, I don't know how big that whole side is, but I know from D prime to D is 40 feet. So that must mean it's how much? Not 40. 40 goes from here to here. I want to know how big is it, this whole side of the triangle. So remember, my triangle starts all the way down here at B. 44 feet. So that's what I would put up in my numerator. That, when I reduce it, first of all, what is 44 divided by 4? That's 11. That should come out to be the exact same as when I match up any other two corresponding sides. So like I could look at the bottom. I know this little bit right here from B to E prime is how big? 3 feet, so I would put that in my denominator. I don't know how big the other side is, but I do know that from E to E prime is 30 more feet. So how big would this whole side of the triangle be then? 33 feet. Is that equal to what we got before? Yeah. So my scale factor is 11. Still haven't found how big it is across the lake. All right, scale factor is equal to new over original. And we said the original triangle is our little triangle. I know now that the scale factor is 11, so in the place of scale factor, I can replace that with the number 11. And I'm going to look at that third side. Big triangle is my new triangle. Do we know how big that big third side is? No, that's what we're looking for. We do know the smaller side. So since I don't know across the lake, I'm just going to call it DE. And how big is the corresponding side on the small triangle? 3.4 feet. So I can put that in my denominator. How do I get DE by itself? How do I get rid of a fraction? Yes, we're going to multiply by that denominator of 3.4 on both sides. So as part of the fraction, the 3.4s cancel out. On the other side, I just need to do 3.4 times 11, which gives me what? 37.4. Is equal to DE. So it is 37.4 feet across the lake. Beautiful. Beautiful, beautiful. Number 4, down at the bottom of the page. Some of this is review. Some of this is answering questions that we didn't ask yet. So it's new information, but it goes along with what we've already learned. When I have a scale factor, remember, a lot of times they'll use K to mean scale factor. When I have a scale factor that's bigger than 1, what do we call that kind of a dilation when the scale factor is bigger than 1? That's an enlargement. When K is 0, my scale factor is 0. We always multiply by the scale factor, right? What happens when I multiply by 0? It equals 0. No matter how big or small the number is, if I multiply it by 0, it becomes 0. That means if my scale factor is 0, that is the center of dilation. Right. I'm going to skip the highlighted ones for a minute here. We'll come to those. I'm going to hop up to the top of the next column. When K is exactly equal to 1, when my scale factor is exactly equal to 1, well, what happens when you multiply by 1? 5 times 1 is 1. 5 times 1 is 5. What is 10 times 1? 10. 50 times 1? 50. So it stays the same. When my scale factor is 1, I'm going to get another shape that is exactly the same size as my original shape. In that case, it would be congruent. I would have 2 figures that are the exact same size and the exact same shape. All right. I'm drawing a little number line so that we can see what we've already said. We said that for things that are bigger than 0, or sorry, bigger than 0, bigger than 1, we call that an enlargement. What would we call it if it's in between 0 and 1? Reduction, absolutely correct. So now I want to look at the negative ones, the ones that are kind of highlighted here. And we're not really going to do much work. Like, you're not going to find problems on your homework like this. But I do want to answer what happens when the scale factor is negative, because that is possible. Let's look at this one first. Where K is less than negative 1. Well, here's negative 1 on my number line. And so less than negative 1 would be pointing out this way. The mirror opposite on my number line would be over here. We call that an enlargement, right? When I'm on the opposite side going the opposite direction, it's still going to be an enlargement. Close. The negative, what it's going to do, it's actually going to rotate our figure 180 degrees. So it's going to make it bigger, but it's also going to flip it around backwards. Have you guys ever seen in a science class, like how your eyes work? Has anybody ever seen that? No? So if you ever have the opportunity, it's kind of cool because it works off of this exact same idea here. When you look at something, that information comes into your eye. The eye is very small compared to most of the other things you're looking at, right? Like if I look at that back wall, that's much bigger than my eye. So what your eye does, the way vision works, it's going to take what you're seeing in front of you, and it's going to bring it together. It meets at your eye. And the light passes through your pupil, and then it projects that image on the back of your eye, but it does it upside down. That's what this negative scale factor does. Your brain projects it, or sorry, your eye projects it on the back of your retina upside down, and then your brain knows that it's got to turn it back around. But your eye itself is taking things and it's doing a negative dilation because it focuses it in, and then it goes beyond that point of focus, and that'll flip it upside down. All right, last piece. I want to see if you guys can guess this one. If we're bigger than 1, that's an enlargement. If I'm smaller than -1, that's an enlargement and a rotation. When we're in between 0 and 1, that's a reduction. What do you think about when we're in between -1 and 0? Reduction and rotation, yes. It's actually still 180. It's always going to flip it exactly upside down. So reduction and rotation of 180 degrees. Like I said, you won't have any homework assignments where we have a negative scale factor. But a lot of times students will ask me, can it be negative? What's happening when it's negative? This is what's going on there. I don't expect you to memorize that part. The reduction and enlargement, I do expect you to know. All right? All right, let's flip this over on the back side. How is a dilation different from things being congruent? How's a dilation different from being congruent? Yes, congruent means not necessarily equal, but same size. Yes, and so we can take things and set them equal if they're congruent. Yes. Congruent means same shape and same size. Yes, yes, that's absolutely correct. Congruence, same size and same shape. Dilation, different size, but still same shape. Right. Number 6, we have this triangle, ABC. And I'm giving you what those coordinates are for A and B and C. I want to take triangle ABC and I want to dilate it with a scale factor of 3. If it's got a scale factor of 3, would we be enlarging this triangle or reducing this triangle? Enlargement or reduction if my scale factor is 3? Enlargement. Does anybody remember from yesterday how I can take my ordered pairs and dilate it with a scale factor? Multiply. What do I multiply by? In this case, 3, because 3 is my scale factor. And which parts of the ordered pair do I multiply, the x or the y? Both. So on point A, we're going to multiply the x by 3 and the y by 3. On point B, we're going to multiply the x by 3 and the y by 3. And same thing on point C, we're going to multiply the x by 3 and the y by 3. So for point A, when I multiply the x and the y by 3, what do I get as my new point? 9, negative 12. What about point B? It was 2, 7, but now it becomes 6, 21. And for C prime, we were negative 1, negative 6. Now it is negative 3 and negative 18. Very nice. For part B, I want to take the same original triangle, triangle ABC, and I want to dilate it this time by a scale factor of 3/4. If my scale factor is 3/4, what's going to happen to my shape? Is it going to get bigger or smaller? Smaller. This would be a reduction. When my scale factor is 3/4, because the numerator is smaller than the denominator, that's going to be a number that's smaller than 1. It's 0.75 when I change it into its decimal form on my calculator. And so because it's between 0 and 1, it's going to be a reduction. All right. So I have my original points, A, B, and C. A was 3, negative 4. B was 2, 7. And C was negative 1, negative 6. What do I need to do with each one of those original points for part B? Multiply it by what? Sorry, by what? By 3/4. Sorry, I just couldn't hear. We're going to multiply the x part and the y part by 3/4. What is 3 times 3/4? 2.25. Depending on the calculator you're using, it might leave it in its fraction form. The fraction form of this would be 9/4. If you're using one of my yellow calculators, it's probably going to leave it in fraction form. If you want the decimal, if it gives you fraction form on the screen after you hit enter and you want the decimal, you need to push this button right here, right above enter, and it'll change it from fraction into decimal. All right, then we still need to do the y part. What is negative 4 times 3/4? Negative 3. Then we do the same thing with point B. We have to multiply the x part and the y part by 3/4. What is 2 times 3/4? 1.5. Or if it's in its fraction form, that would be 3/2. And 7 times 3/4. 5.25. Do I mind if you leave it in its fraction form? Not necessarily. The only time that you would probably want to make sure it's in its decimal form is if you're going to plot points, because the fraction form is really hard to find on the number line. And so then I would definitely change it to its decimal form. But fraction form is always fine. What about for point C? What is my new x part? Negative 0.75 or negative 3/4. And what about the y part? Negative 4.5, or in its fraction form, negative 9/2. Last part of this question, part C. It's way down at the very, 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 very bottom of my screen. I apologize for it being so low. That makes it hard to see from the back, so I'm sorry, guys. In this case, we already have our dilation. We have our new triangle, A triple prime, B triple prime, C triple prime. They gave us the ordered pairs for this, and they want me to find K. What's K again? What does that mean? Scale factor. Well, I know that scale factor is new over original. And like we saw on the second thing that we did on the first page, my scale factor applies for every single pair of corresponding sides. Right up here, in order to get these new ordered pairs, we multiplied both the x and the y by whatever our scale factor was. So if I know what the ordered pairs are already, and I'm trying to find the scale factor, I need to pick one of these points, and then I go with the corresponding original point. Do you guys want to go with A, B, or C? A sounds good. I don't even need to use both the x part and the y part. I only need to use one piece of it. Do you guys want to use the x part or the y part of point A triple prime down here? Y part sounds good. You're going to get the same answer no matter which one you choose, but some numbers are easier to work with than others. All right, so this is my new. That's going to go in my numerator. So -2. Original, I have to come up here to these original ordered pairs, and I have to find the corresponding piece. We went with A or B or C down here. A. So up here, I would have to go with point A. Did I use the x part or the y part down here? So I have to use the y part up here. What's the y part of A? -4. And now I have to make sure that my fraction is in simplest form. First thing I notice about this fraction is the top and the bottom are both negative. What's a negative divided by a negative? Positive. So this becomes a positive. 2/4. Can I reduce that? Yes. What goes into both 2 and 4? 2 goes into both of those. So my scale factor in fully simplified form would be 1/2. Nice work. All right. When shapes are dilated, the polygons or the shapes we say are similar. And we use that single squiggle to mean similar. Corresponding sides on my similar shapes are proportional. We said yesterday that proportional means I'm going to have fractions that are equal to other fractions. Corresponding angles, though, are congruent. The angles being congruent is what keeps my shapes the same shape. That's why it doesn't become a different shape when I do a dilation. The sides are proportional, they change size, but the angles are going to be the exact same size. They're going to be congruent. All right, let's look at number 7. We've got this weird notation down here. I have xy equals, and then it says 3x, 3y. That 3 in front of both the x and the y, that 3 is being multiplied to each of those. This is k. That's my scale factor. So I have point A here. Point A is -610. I want to apply this transformation with the scale factor to get A prime. So what do I have to do to both the x part and the y part here? Multiply them both by 3. So my point A prime would have what as its ordered pair? -18, and I'm sorry, I didn't hear the second number. 30. There's my point A prime. How would you describe this dilation? Did we just make it bigger with an enlargement or smaller with a reduction? Bigger with an enlargement. Right. We have just a little bit more to do. Flip the page over. We are going to skip a couple for time. We're going to skip number 8 for time. And we're going to skip number 9, part A. We're going to do part B, though. Part B, they have a triangle drawn for us. And then up above it says K equals 0.5. What does K mean again? Scale factor. And if my scale factor is 0.5, is this an enlargement or a reduction? Reduction. So I can come down and put that on this line where it says dilation is this is a reduction. All right, let's go through and do this. I need my original ordered pairs for L, N, and M. What's the ordered pair for L? -5, 10. What about for N? -10, 5. And M? -10, 0. And what do I have to do to both the X parts and the Y parts for each of those? Multiply by 0.5. Well, what is -5 times 0.5? -2.5. What is 10 times 0.5? 5. So my point L prime is at -2.55 right here on my graph. And then we're going to do the same thing with point N. What's -10 times 0.5? -5. And what is 5 times -5? 2.5. So -5, 2.5. -5 up 2.5. There's my N prime. And then what about for M? What is that transformed point going to be when I multiply both the X and the Y by 0.5? -5, 0. So right here is my M prime. Then I grab my straight edge and I connect those points to make my dilated triangle. And I would say that triangle LMN is similar to triangle L prime, M prime, N prime. Last two problems. They're very fast, but you do have ones like this on your homework, so I want to make sure that we're going over how to do this. Here, I'm supposed to find the scale factor. Well, I know that scale factor is new over original. I've got 3 points on both of my triangles. I only need to pick 1 point that's corresponding between each of these triangles. Do you guys want to go with point A, point B, or point C? C is the first one that I heard. If you said a different one first, I'm sorry. What's the ordered pair for point C? 2, 0. What would that correspond to on the other triangle? 4, 0, point C prime. Which one of these triangles do you think is my new triangle? ABC or A prime, B prime, C prime? The primes. This is my new. And this is my original. So when I do new over original, can I use the Y part over the Y part like we did before? Why not? They're both zeros. I'd have 0 over 0. That's not going to help me find my scale factor. So the only numbers I don't want to use when I'm trying to find scale factors, anything with zeros in it. So what should my fraction look like? 4 over 2. Is that fully simplified? What is 4 over 2? 2 over 1, or just 2 in fully simplified form. So my scale factor here is 2. Let's do part B real quick so that we get one more piece of practice like that. All right, so scale factor is new over original. We got to pick one of our points. Do you guys want X, Y, or Z?
Z.
Y is the first one that I heard. Does it matter which one you pick? Nope. What is the ordered pair for Y? Negative 3, 6, right? Unless I'm reading it wrong. It's 3. Yeah, negative 3, 6. What about Y prime? What's that ordered pair? Negative 1, 2. We have to decide whether we're going to use the X part or the Y part. Do you guys want to use X or Y? Y sounds good. So when we do new over original, what goes in my numerator? 2 goes in the numerator. What goes in the denominator? 6, because I have to use the corresponding part. Is 2 over 6 in simplest form? No. What do I have to do? Simplify top and bottom by dividing them by 2. And this gives me what for my final answer? 1/3. Fantastic work today, guys. There's one last piece that I just want to show you very quickly. It's no work. You can pack your stuff up. I want to show you on Canvas where you can find the videos in case you miss class, or if you just want to watch class again because you don't remember how to do a certain problem. I also post the notes there. So give me just 1 second. I'll get that pulled up.